Hello, Matt G for IYT here, and today we're looking at the full license mock examination number 1 version 1.6, and we've reached question 21, which reads: the lookup table in a direct digital synthesizer A records the frequency, step size and maximum/minimum frequencies. B contains the amplitude of a sine wave at different points in the cycle. C keeps track of the division ratio of the VFO output signal. Or D contains frequency corrections for the temperature of a crystal reference. So we're being asked about this device, the direct digital synthesizer, and a synthesizer is something that can be used to produce a waveform at a particular frequency, and in the direct digital synthesizer is kind of a special case of that, and there's an example, or a block diagram rather, for one in the full license manual here. We can see we've got a frequency control which drives a clock, and we'll get to why we have that in a second, and then that is causing these values from what's called a sine wave lookup table to be fed into a digital to analog converter, and then we filter the output and we get our sine wave. Well, the block diagram kind of explains all the parts but doesn't do a great job of explaining what's happening, and if we were to draw a sine wave here like this, and we can see that at this point it's not a very good 0, but it's a 0. At this point 0, 0, 0, and at this point we might use the amplitude might be 255, and at this point it might be minus 255. And that might seem like a weird number, but it's a computer system that will work in powers of 2. Minus 255, or 255 would be 2 to the power of 8, so it kind of makes sense. And maybe in between we've got 128 here. And 128 here. So effectively there's a list of numbers that would say 0, 128, 255, then 128 again, and then 0, and then minus 128, and so on. And you've effectively got a list of numbers which describes this waveform. And there's an even better example of that in this image here, which shows that each of these steps is effectively an entry in that lookup table, and all that's happening is that the device is running through that lookup table and it's setting its output, it's sending that to an analog to digital converter. So here it's saying the value is 0, it'll be 0 volts, and maybe here it's 128, so the value is halfway up, and here it's 255, so it's at the top of the whatever the maximum voltage output is. And we can see here this is quite jagged. Well, if we put a point in between each one of these, then it'd be slightly less jagged, wouldn't it? Or if for every 1 point it was 10 points, then it would be even less jagged, it'd be nice and smooth. So the number of points in your lookup table really determines the resolution or the smoothness of the curve of the sine wave. And of course you could filter this jagged curve and you can get something like that looks a bit more like a sine wave, or you can have an even smoother one and then filter that and get an even smoother output. So that's how you could produce a waveform, a sine waveform, or indeed any other waveform. You just change the values that you put in your lookup table. The block diagram actually talks about another part as well, which is the frequency control. Well, I may go through each one of these values. If there's 100 values to describe my sine wave, and I go through 100 values a second, I'm generating a wave at 1 hertz. If I want to go faster, then I need to go. If I want to go twice as fast, then I need to process 200 values a second, and so on. So the clock and the frequency control to vary the clock determines how quickly the device is rattling through all those values in that table. So it's just a list of numbers that are used to produce a given waveform, and that could be a sine wave, it could be a triangle wave, it could be a square wave, even if that's what you really wanted to do. And of course you can get all kinds of programmable direct digital synthesizers that can do all kinds of things. So let's go back to our answers and see which sticks. So we've got answer A, the direct digital synthesizer records the frequency, step size, and maximum/minimum frequencies. Well, it doesn't record the frequency, it doesn't record the step size, and there's no minimum and maximum, so that one's right out. B contains the amplitude of a sine wave at different points in the cycle. That actually sounds exactly like what we've just described, so let's just put a marker by that one. C keeps track of the division ratio of the VFO output signal. I've not really been talking about VFOs. You could maybe use something like this to be a VFO or control a VFO somehow, but no, that doesn't really sound like the right answer. or D, contains frequency corrections for the temperature of the crystal reference. Well, again, if it's the reference for the synthesizer itself, yeah, I'm not quite sure how that would work. That also doesn't sound like it fits. So we are left with B as the only reasonable sounding answer. Let's skip down to the answer to see if we got that right. And yes, of course, for question 21, we can see that it is B. Thank you very much. I'll catch you for the next one.